Okay, for today's notes, we're going to solve absolute value inequality, which is just like the absolute value, but now we have an inequality instead of an equal sign. Because it's also an absolute value, we're going to follow the same steps. I'm going to start with isolate. I always color code it so you can recognize where the step is and how it works. For isolate, we highlight the absolute value from line to line, and it will check if there's a neighbor outside of the line. In this problem, there's no neighbor, so I can go ahead and do the second step, which is to separate. When I separate, I need to make sure that on my negative side, I'm being careful because my negative side is going to look a little bit different than what it's looked like before. My positive is going to be exactly the same. They both have x plus 7. The positive is going to stay exactly the same. But for the negative, I am going to flip and change. So my 2 does become negative. That's what when it's changed, we're going to change the sign. But my inequality is going to flip around. After that step, I can continue to solve. When I solve, I draw my line, and then I get the x by itself. I isolate the x, so I get rid of the 7, and I have x and a negative 9. So I have x is greater than or equal to negative 9. And I have, on the positive side, x and a negative 5. So x is less than or equal to negative 5. So I do have 2 answers again, but now I'm going to try and put them on a graph. I'm going to put my answers on a graph. Here's my number line. On it, all I need is my negative 9 and my negative 5. Since they are both have an equal sign, I'm going to go ahead and do a closed circle for both. Here, I have x is greater than negative 9. Negative 8 is greater than negative 9, so it's negative 7. So we're going to go this way. Negative 5, for negative 5, I have x is less than negative 5. So numbers less than negative 5 are negative 6, negative 7, so we're going to go that way. So the arrows are kind of going towards each other. That means my graph looks like this. 2 closed circles that are connected. And we can double check that by going back to the original problem. My problem has a less than sign. That means my solution looks like a sandwich. Sandwich means anything that's on between these 2 breads, anything that's here in the middle, is a solution, like negative 8, negative 7, negative 6, negative 6.5. Everything that's here between these 2 points is a solution. Now, because we've seen that graph before in this class, we're going to convert it to interval notation, and if possible, inequality and set builder notation. For interval, they're both closed, so I do brackets. For inequality, negative 9, negative 5, x goes on the middle. We always do less than and then line because they're closed. And for set builder, we'll just drop down that down with the curly brace and everything around it. And that's my answer. Okay, here we have the second question. We're going to do the same steps. Starts with isolate. Notice this one we do have to isolate because my absolute value has 2 neighbors, a 4 and a 1. We always start by adding or subtracting first. So when we subtract the 1, we get greater than 20. I still need to get rid of the 4 because my absolute value is not quite isolated. So I'm going to divide by 4. That means I have absolute value of 2x minus 5 greater than 5. Now that I've isolated, I can move on to my second step, which is to separate. Again, this is the one you have to be careful because for the negative side, we're going to flip and change. So I keep what I had highlighted, and then I flip and change. For my positive side, everything stays exactly the same. And now I am going to solve. Draw my line at the 5, that's 0, divide by 2, that's 0. Draw my line at the 5, divide by 2. That's 5. Now, because I have to graph it, I'm going to do a number line. I always want you to graph your answer. It matters. It makes a difference. So I have a 0 and a 5. At the 0, my answer is x is less than 0. If it's less than, the numbers have to be getting smaller. So we're going this way to negative infinity. No equal sign, so it's open. At 5, it's also open because there's no equal sign, and my x's are greater than. Greater than means we're going to the right side to positive infinity. So notice this graph looks different than the first question. And the reason for that is on my problem here, after I isolate, I have a great OR problem. That OR is very, very important. That OR means that the lines are not going towards each other. So we have two different answers. So when I do interval notation, I have to do one for the left arrow and one for the right arrow. So on the left arrow is going to the left towards negative infinity. And it starts at 0 with an open circle, so it's parentheses. Or I have the one on the right side that starts at 5 and it goes forever to positive infinity. That means for inequality, I'm going to have two different inequalities. I have the x is less than 0 or x is greater than 5 from here. You can just put those in set builder. Curly x such that x is less than 0 or x is greater than 5. Like that. Okay, for these next two questions, let's talk about special solutions. I have my absolute value isolated and it's less than a negative number. Remember from equations, whenever we have a negative number, we have a special case. So let's look at it. Here I have my absolute value. Absolute value is distance. It's the definition of distance from 0. And distance always have to be positive. So distance is always positive. So because of that, here I have a positive thing. I have distance less than a negative number. A positive number can never be less than a negative. So this is a false statement. And that's what makes this one a no solution. Because I have a less than symbol, less than a negative, I have no solution. For question 4, however, it's a little bit backwards. I have my absolute value, which is positive, being greater than a negative number. A positive number will always be greater than negative. 5 is greater than negative 1. So because that's always true, my answer is all real numbers. It's always true, so everything's going to work. It also looks like that. It's just a little, this is just a little math symbol that mathematicians use because they're too lazy to write all 3 words. So it just looks like this. Okay. For this last question, we have computer prices. We are at Best Buy and we're trying to buy a computer and there's 10 of them. But I am smart and I don't want to buy the cheapest one because they break down. I also don't want to buy the most expensive ones because they're too overpriced. So I'm figuring out that I want to see what the average is. I want to see the average price. So let me put that here. Find average price. And then maybe not just buy like that one that's on the average, but like I'm willing to spend $100 more or less than the average price. So this takes us back to the equation that we used for solving absolute value equations. And it looks kind of like this, where you need a number here and here. We're not going to do an equal sign here because this is inequality. So we're going to figure out what inequality we need here. And then remember here, the number here is my halfway or my average. again, I'm going to find the average between all these numbers. We're going to add them on the calculator and divide by 10 because there's 10 calculators in total. When I did that, my average was 664. And then the number here is how much I want to deviate or vary by. In this case, I'm going to vary by $100. I'm willing to spend $100 more than the average or less than the average. So that's what's going to go here, my 100. Now, what inequality do I do here? So let's look at the number line to try to make sense of it, like where that inequality comes from. I have 664 in the middle. If I vary by 100, I'm willing to spend 764 as my maximum, or 564 as my minimum. Am I willing to spend 500? No, because it's not like within the $100 limit. I'm also not willing to spend 800 because it's not within the $100 limit. So because I'm only looking at everything that's between these two numbers, that looks like an AND graph. I'm going to do the lines that go like that and connect them. This looks like an AND problem. So I'm going to do a less than or equal to because I can spend the $100 more, the 764. And so now with that information, I can see that this computer is too overpriced. 725 is fine. 650 is fine. 750 is fine. 825 is too overpriced. 370 and 450 are too cheap. So I can only pick between 1, 2, 3, 4, 5, 6 computers. I only have 6 options to pick from. The last thing I want to point out is that whenever you divide by a negative, you have to flip our inequality. So here I cannot add the 10. I have to divide by it because it's not x minus 10. I'm multiplying, so I divide. Whenever I divide, we flip the inequality. So it will look something like that. So whenever you divide on your notes by a negative or on your work, whenever you divide by a negative, I flip my inequality. I don't care if the number on the other side of the inequality is positive or negative. Here I am dividing by positive 2. Because I'm dividing by a positive, I don't care that the 4 is negative. I don't have to flip there. So that's the last thing I wanted to mention.